Okay, Humam, today is our first class on computing mathematics. My name is Maria Fleur, and I'm going to represent my slides. In these slides, I will explain that in today's lecture, I will explain that explaining why mathematics is important in computer and how many types of mathematics are used in computer programming, right? Do you
Okay,
have
miss.
any idea about computer programming and mathematics, that how they are linked, or
Yes,
what is the basic function of mathematics and computer programming?
yes, miss. I do have a little bit idea.
Okay, tell me that how computer or how mathematics is used in computer programming.
To make things easier,
Okay,
like easy.
okay. You know that mathematics makes algorithm easy for us, right? We found it easy to make logarithms in computers when we are an expert of mathematics, right? Basically, what computer programs are? Computer program are basically the mix and matches of algorithms, right? With correct algorithm we can make a program, and then with correct algorithm we can you can say develop a computer program or computing program, right? Then
Yes, miss.
there are basically a set of instructions that demonstrate the implementation of a program or an application. Mathematics is actually very important in learning the basic uses of logarithms that are utilized in an advanced form or in computer science. For example, Humam, I want to make a GPS app, right? I want to make a global positioning system app, and in that app I will you can say what will I do? I will develop an algorithm, and through that algorithm I will set some coordinates in the world that where I want to pin some location, right? And after setting those coordinates, I will just apply or execute the program, and then I am able to pin some location over the world, right? So what happens that first of all we have to make an algorithm, right? When we make a correct algorithm, when we make a suitable algorithm, our computer program is very easy to develop, right?
Yes, miss.
Okay, next we have the importance of mathematics in computer science, right? Now they are saying that following programs or following points teaches us the importance of mathematics, right? First of all, discrete mathematics is the foundation of computer science, right? You have to, you can say, you have to fix this thing in your head that discrete mathematics is one of the foundation in computer science, right? Then when we know how our mathematics work, we are able to use a logarithm. Then we will have mathematics that provides analytical skills required in computer science, right? For example, what are analytical skills? Do you have any idea about analytical skills?
No, miss.
No? Okay, analytical skills are the foundation for artificial intelligence, right? For example, in if you have developed a robot, right? A robot program, okay? A robotic program, and you have introduced artificial intelligence in it. Okay, we all know that computer cannot make decisions, right? Why it
Yes,
is
miss.
that? Because he don't have you can say decision making powers, right? But now what is happening that some of the scientists have developed such you can say formulas, or you can say such intelligence. You know about AI, right?
Yes, miss.
Okay, do you know about Tesla?
Yes, miss. I do know about Tesla.
What is Tesla? Tell me then.
It's an electric car that drives on itself. It's totally based on AI,
Okay.
uh, using sensors and taking information surrounding it, and it drives according to it. Autopilot and all the stuff it has. So it completes its own decision that shall I change the lane? Is it safe to do, or is it safe to turn, like that?
And how this is doing that? These are the you can say a set of analytical skills that have been developed in, you can say, Tesla, that is being feeded in Tesla. Because of those analytical skill sets, Tesla is able to drive a car, right? Tesla is
Yeah.
able to drive our way to our destination, right? There have been many cars in, you can say, past which have you can say global position system, and they were able to drive. But Tesla, why Tesla is you can say more accurate from them, because Tesla have artificial you can say intelligence, right? These are the analytical skill set which able a thing, or you can say a gadget, electronical gadget, to make decisions, right? For example, if Tesla is observing a car coming from lane 2 and you are driving in lane 1, and Tesla just observed that after 2 minutes the car will overtake you, right? Then what Tesla will do? Tesla will slow their speed, right? And when it will happen when Tesla is able to analyze the analytical tools, right? Or analytical skill set, when Tesla have that, right? So artificial intelligence have analytical skills, right? In computer, and when we develop analytical skills, we develop artificial intelligence. Now we have mathematical concepts are required in many disciplines of computer science. Okay, not in just one discipline of computer science. There are many other disciplines of computer science in which mathematical concepts are required. Now we have discrete mathematics as the foundation of computer science, right? So the slide says that, ever heard of the logic notation, set theory, combinatorics, or you can say graph theory, probability, number theory, algebra, etc. Do you have you ever learned any of these things, Umam?
Yes, few of them.
Few of them. Okay. Have you learned probability?
Yes,
What is probability?
like it's I've learned it in I think grade 9
Okay.
of 10.
So do you have any idea what was probability about?
Not much.
Okay, probability is basically about that you have to, you can say, you have to speculate, right, about the upcoming events, right? That how much, for example, if you roll a dice, right, a dice have six figures, right? One, two, three, four, and five. Five and six, sorry. So you will, through probability, you will just speculate that if I you can say roll dice twice, what are the probability of having six, right? In every time. So you will, you can say, learn that what are the basic, what is the basic, you have to speculate that, or you can say you have to predict about that, what is the upcoming behavior, and how you speculate, what is the an upcoming event, and how you speculate that, you speculate by reading the history, right? Reading the history, observing the previous behavior of people or object or events. You just you can say go through them, and you predict that in history this event has occurred this time. For example, in history you have rolled a dice twice, and what happens that there was two times you were able to, you can say, roll six, or you were able to have six, right? So what will you do? You will speculate that in, you can say, in upcoming event, you also have a, you can say, a chance of having that dice, you can say three times, or you can say one time, right? One to three times you will say that there are, you can say, events that you can have six, right, on rolling a dice. Okay. Next, we have combinatories. Combinatories is that in which we, you can say, we just learn about that. For example, you have A, B, and C, right? How many combination you will make, or how many combination you have if you have those elements is single, if you have those element in doubles, and if you have that element in whole form, right? So you will predict those combinations as well. Then you have graph theory. know that whenever we just read about, or you can say observe something, right? For example, you are observing weather of a city, right? And you see that in day one they have 40 degrees centigrade, in day two they have 45 degrees centigrade, in day three they have 43 degrees centigrade. What will you do? You will draw a graph and you will explain to the people who are the person who are interested in results, right? And how you will explain them? You will explain them in the form of graph, right? In
Yes,
the graph presentation make that data more you can say understandable for those people. Am I right?
yes, miss.
So how these things are made easy? These things are made easy by computers and the combination of mathematics, right? Okay, so the thing that I have explained you, they are a part of discrete mathematics, right? And discrete mathematics is also a foundational part of programming in computer sciences, right? For example, if we take an example, so the primary example we have is algebra, right? Have you ever heard about the Boolean algebra?
No, miss.
Okay,
Yes, miss. I have heard, but I don't have much knowledge about it.
okay. Basically, Boolean algebra depends upon the truth gates, right? For example, if we are developing logic gates, right, we need Boolean algebra in it, right? In it, right? And what happens that we say that, for example, if we have zero in one case and one in other case, what will be the, you can say, answer in that case, right? So these are using when we are going towards the algorithm which depends upon the logics, right? We use Boolean algebra. And what is Boolean algebra? Boolean algebra is you can say combination of the mathematical algebra, which is from discrete mathematics, and the learning gates which are from you can say physics and as well as computers. So what happens that the binary language that we have in computer 0 and 1, we just take help from that, and what we develop a Boolean algebra which help us to solve some of the logical questions, right?
Yes, miss.
If you have so far any questions you can ask.
No, miss.
Are you sure?
Yes.
Okay. Now we have mathematics teaches the uses of algorithms, right? Do you know about ALU and CU?
No, miss.
ALU is the arithmetical and logical unit in you can say computers, and CUs are the control units of computer, right? Which are these both units are in CPU in a computer, right? So what happens that when we develop a program is a combination of you can say arithmetics algorithms and logical algorithms, right? Both of these you can say combine, and what happens next then ALU programs are you can say developed. What are ALU programs? ALU programs are arithmetical and logical programs, right?
Yes, miss.
So in this slide, they are telling us that algorithms are a fundamental part of computer science, and all of you must have heard of them in one way or another way, right? They are basically a set of instructions that demonstrate the implementation of a program or an application. For example, someone is developing an application, right? About, for example, do you have interest in any application and you have so further, you can say, seen the programming behind that application? Have you ever?
Yes, miss. I have seen the first-person shooting games. I've just seen how they're developed and the behind the scenes and all this stuff.
Okay. So basically, what happens that they have, you can say, algorithmic programs in which they develop, you can say, set of instructions, right? Basically, programming is what they are the set of instruction, right? For example, if I Google you something, so you can see here what I'm showing you, right? These are, for example, these are the set of you can say programming lines. These are the programming lines. You can say these are the programming codes, right?
Yes, miss.
Okay, so what happened? For example, if I am developing any application, I will define that application, or you can say I will make an application and I will make my own program, right? In these type of sentences, I will make the programming code, and then what I will do, I will go toward the execute button, and I will, when I will make this, right, I will execute the program. And what will happen? I will be able to perform a, I will be able to develop a program. Now they are saying, now where did you first use an logarithm? But it was not the computer science, but a class, but actually the mathematics class. Don't believe me? Well, 2 plus 3 is equal to 5 is a basic logarithm you learned in mathematics class that demonstrate the sum of 2 plus and 3 is 5, right? And mathematics is actually very important in learning the basic uses of a logarithm that are utilized in the advanced form of computer science.
Yes, miss.
Okay, so you have been using, you can say, a logarithm in very, you can say, from very old time, right? But the difference is that you never knew about, right?
Yes, miss.
When we say 2 plus 5 is equal to 5, right? What are we doing? What is this? When you write this in this, you can say, arrangement, that you write first 2, then you add the addition sign, then you write 3, and then you add the is equal to sign symbol, and then you write the answer of this. What are you doing? You are making an logarithm, right? You are making a line of execution, but the difference is that this algorithm belongs to mathematics. This algorithm doesn't belong to computer. That's why this is the basic logarithms, right? And what is this? And when, for example, you add a minus sign, for example, I am adding a minus sign in it, right?
It's two.
So what I have done, I have basically, you can say, made an you can say make an another logarithm, right? But that logarithm is belonging to mathematics, right? In
Yes,
computer science, we just move toward the, you can say, more advanced form of this logarithm. Okay. Now we have mathematics provides the analytical skills required in computer science. Okay, I have told you about the analytical skills. What are the analytical skills? Analytical skills are basically the skills which are used to resolve some problem, plus they are also used to analyze some data, and also they are used in making some decisions, right? For example, if I want to make a decision, for example, you are in Tesla, right? And your navigator is, GPS is saying that turn right after 200, you can say, 200 meters, right? So if the Tesla is not listening this, you can say, completely, and it have only learned that you have to turn right. If the Tesla haven't heard 200 after 200 meter, so if it is about to turn right, when then he will analyze that whether I have a right turn over right, over, you can say, whether I have a right turn now, or there is no right turn. And plus it will also analyze that whether, it will also analyze that whether I have to, you can say, turn right now or after 200 centimeter. So what is happening, that for example, mathematics is the basically foundation when we are designing or developing some kind of analytical tool in computer science, right? And what is happening, so we can also say that mathematics, which we use in computer science, also help us to develop, you can say, the artificial intelligence, right, in
yes,
things.
miss.
Okay, you can read the slide, and if you have any queries about it, you can ask from me.
Okay, miss. Yes, miss. I've read it and I have no doubts.
Okay, so you have any queries about the slide?
No, miss.
You can read this as well. Have you read this?
Miss, I'm reading it. Yes, miss. I've read it.
Okay. So now let's have a look at what we have in this slide. They say that mathematical concepts are required in many disciplines of computer sciences, right? So we will see that. Whether we have those, you can say, whether the maths is playing a you can say foundational role in many disciplines of computer science or not. Okay, so they are saying that computer science is an umbrella term that contains many disciplines like operating system, databases, networking, artificial intelligence, embedded system, data analytics, and much more, right? And much more from there, right? For example, if we take an example of operating system, so
Embedded system?
yes,
What are embedded systems?
embedded system, you're talking about embedded system. Okay, I will tell you. Embedded system are basically sorry. Embedded system are these are those systems which are used in computer systems, which are combination of computer process, computer memory, and input or output devices or peripheral devices, right? For example, have you ever seen, you can say, a motherboard,
Yes, miss.
right?
Yes,
Have
miss.
you ever seen a motherboard? Okay, let me Google it so that
Yes, miss. It's a green color chip with so many components on it.
what is basically an embed system. It is, you can say, it is a system that, for example, I'm using this PC, right? This PC have an embedded system in it, right? On
Yes, miss.
which I am working, right? For example, let me show you. Okay? Okay, these are the images. See, this is an embed system, right? It have basically, for example, sensors. It have controller software, clock, operator, display, and then they have, you can say, actuators, right? So these chips are basically in these chips, or you can say in this board. Basically different systems are being embedded over, right? And what is
Yes, miss.
happening then, then after this embedded system will be connected with, you can say, wires, and then it will be put in, you can say, in a laptop, or you can say in a computer, right? PC. So hopefully you have been understand about the embedded system, right? Okay,
Yes, miss.
then we have data analytics. Data analytics are basically, these are the programs which are, you can say, able to analyze the data sequences, right? For example, in 19, for example, if I got some primary data about that, for example, I have, you can say, in 1990, the population of Pakistan was 21 crores, right? And after in 1991, what happens that 21 crores, because then there was a slightly, you can say, increase in population. It become 21 crore point one, right? And after that, in next year, it become 21.5%. Oh, sorry, 5 crores, right? So what is happening? I am analyzing the. I have some of the primary data, and then I am able to analyze that data, right? And then I will put that data in analytics, analytical programs. What they will show me? They will show me a pattern, or you can say they will show me a growth rate, which will show me that the population is increasing by this rate in following 10 years or in back 10 years, right? So what are they saying? They are saying that, for example, fields like artificial intelligence and machine learning require a thorough knowledge about mathematical concepts like linear algebra, multivariable calculus, probability, and theory, right? Probability is basically, you can say, a branch of computer which will help you thoroughly to, you can say, to understand about the, you can say, artificial intelligence, right? Because artificial intelligence is all about the events that occur in, you can say, history, and then you have to take or predict an event in, which is going to happen in future, and then by observing the patterns that have done in, you can say, history, you have to predict the upcoming event. Okay, so that, you can say that it helps a lot in understanding the machine or robotics, right? Now in next slide we have types of mathematics that are used in computer programming. So we have big five major maths that are used in computer programming. They are binary mathematics, college algebra, They are statistics, they are calculus, and they are discrete math. Okay, what is binary mathematics? Do you have any idea about it?
No, miss, I don't have any idea about
Any idea about college algebra,
it. No.
statistics?
College algebra is you mean equations?
Yes, the type of algebra that have you learned in your at your college level, right? Which contains equations, which contains geometrical analysis of
Question.
shape, or you can say predicting a shape, or you can say proving that if this is a parallelogram or a triangle, or you can say a circle, right? Okay, so next we have statistics, and then we have calculus and discrete math. So what
Statistics
is, yes, yes,
graphs.
please.
Statistics are graphs, right? Related to graphs and
Yes, statistics is related to graph and related to data classification, right? For example, if I'm giving you some stats that in XYZ city there lives, you can say, 5 lakhs people, okay, or you can say that 5 million people, right? Lives in an XYZ city. And what will happen? I will say that they 40% of this population is female, and 60% of this population is male, right? And in male, there are then I say you that in males, there is 60% of people who are adult. 20% of people are, you can say, they are children, and the remaining 20% are, you can say, old age people, right? Old means. Then similarly, I tell you about the female. So you have this, you can say, stats about a city, and what will you do? You will then apply it on. You can say you will arrange this data, and then you will make a graph, right? And when you will make a graph, it will help you to explain other people about, you can say that about the population of that a specific city. Okay.
yes, miss.
Okay. Binary maths. Binary maths is the heart of computer operation, and among the most essential types of maths used in computer science. Binary is used to symbolize every number within the computer. The binary number system is an alternative to the decimal system. They using this system simplifies computer design. Read and simple mathematical operations are vital for hardware. Low-level programming, knowing how to work with the hexadecimal number system is necessary for various programming functions, including setting the color of an item. Standard arithmetic is utilized in numerous functions of computer programming in nearly every written program. Addition, subtraction, multiplication, and division area used. Have you ever learned about the binary algebra, or you can say binary mathematics?
No, miss.
Okay, binary math is the combination of one and zeros, right? Binary basically means bi means two and nary means numbers, right? Two numbers. So which two numbers are there which are used in computer?
Zeros.
Zero and one, right? Okay, so this is basically the binary mathematics in which we use. Okay, this one is binary mathematics, right? Zero one zero one zero one or 1 0, whatever the number combination is.
Yes.
These are the basically binary mathematics. Okay. And what are the decimal values? Decimal values are the values that occur in, you can say, the number you use usually is 0 1 2 3 4 5 6 7 8 9, right? From 0 to 9, these are the decimal values, right? Or you can say decimal mathematics. What are binary mathematics? They are the math that consists on zero and ones is known as binary, right? Binary means bi means two and nary means number. And what are those two numbers? Those two numbers are zeros and ones. So far, so good.
Yes, miss.
Okay, if you think that there is a point that where you are not able to understand anything, you can ask for me, right? Now read out this one time so that you can have clear, you can say, explanation of this slide.
Yes, miss, I have read it.
Any confusion? Any questions?
Yes, miss. Miss, what are hexadecimal numbers?
Decimal numbers are basically the numbers that consist from 0 to 5, right? 0, 1, 2, 3, 4, 5. Okay, there are six numbers: 0, 1, 2, 3, 4, 5. So
Okay,
basically, we have three type of counting: the binary in math, the hexadecimal math, and you can say the decimal number systems, right?
okay, miss.
Okay, now we have college algebra. Just read this slide so you will be able to understand this. Okay.
Okay, miss. Yes, miss, I have read it.
Okay. What do they say? They say that college algebra covers various concepts, right?
Yes, miss.
What are those various concepts? They are linear equations. Linear equations are basically equations which have variables having powers is equal to ones, right?
Yes,
Then they
miss.
have operations of these linear equations, right? Like for example, adding two linear equations, subtracting two linear equations, multiplication of two linear equations, and division of linear equations, right? Then they have factorization of those linear equations, adding exponents to this polynomials, quadratic equations. Do you know about quadratic equations?
Yes, miss. Which have the equal sign between them?
No, no, no. Quadratic equation is a formula which looks like this. Okay.
Plus minus AB square, something like that.
Okay. It's like b square under root plus minus.
Yes, miss, I know about that.
This is basically the quadratic formula, right?
Yes, miss.
This quadratic formula is very important in computer programming, right? For example, when we have some of the, you can say, a variable that is occurring time to time, which cannot be resolved by us. For example, a problem is, then we name that problem as x, and what will we do? We will just find the value of that x through the quadratic equation. Okay, then what is happening? Okay, then we have rational expression, we have radicals, we have ratios, we have proportions, and rectangular coordinates. Okay,
Yes, miss.
these rectangular coordinates are really, really very important, right? They help us, for example, let me give you an example. Do you ever use Google Maps?
Yes, miss, I always use Google Maps.
Okay, have you ever thought that what is the math between that Google Maps?
No, miss.
Have you learned about vectors in physics?
Yes, I have learned my vectors, but I don't remember much.
Okay, have you ever learned about the coordinates of a vector?
Coordinates of a vector, yes, kind of.
Okay, the satellites that are our world is covered by three main satellites, right? These satellites, and you also know that Earth is of an sphere shape,
Yes,
right?
miss.
It's like a big ball, and if it's like a big ball, then it will have a circumference of 360 degrees, right?
Yes, miss.
So, what is done that three main satellites are operating what? They are operating global positioning system, right? They covered 120 degree, 120 degree, 120 degree of Earth. And what will they do after that? After that, they just use the rectangular coordinate system, right? And what is that? That, for example, you are moving somewhere, right? And what will happen, they will take you as a vector, right? Because you will have some direction and you will also have some magnitude. They will you can say exemplify or suppose you as a vector. And what will they do, they will then calculate your x and y coordinates, right? And then they
Yes,
will found you on the earth that where you are, and then they will locate the location that or your destination that you have, you can say, installed or pinned over that map, right? And then they will, you can say, give you the route that is more feasible, or you can say more short to you, and you can go through that route, right? And so you can say that the science behind the GPS system is rectangular coordinate system, right?
Yes, miss.
That algebra is so helpful in making you can say the GPS system. Okay. Then we have
Yes,
it focuses on algebraic relationship, graphs and function, and students learn to solve from one or two unknown variables in various you can say complex equations. And what will happen that through these complex equations you will be able to resolve the equation, and when you resolve that equation you will find the value of s, or you can find the value of the variable that you have put in it, right? So a student also learn how graph algebraic functions, or for example, algebra is used in computer science in the development of algorithm and software for working with, right? You will
yes,
use algebra, and you will use you can say these algebraic expression will be helpful to you to make you can say you will use that in your computer science, and you can develop an algorithm from that, and that algorithm will help you to make a software working for yourself, and whatever the needs and wants that you expect from that software to cover, you will be able to cover that from others, right? For example, if I will give you an example of GPS, whichever when the Google were you can say developing that program, what you will say you they also have you can say they make a coordinate system, they made some equations to it, and then they solve those equations, and then they design some formulas which will help the GPS system to you can say solve, and then by developing such algorithms they are now able to position anyone or and everyone in the whole you can say on the whole earth, right? And that is
yes,
made so easy for us that we can do it by clicking some tabs, or you can say by clicking some numbers.
yes, miss.
Anything you want to ask me about this slide, you can ask.
No, miss, it's clear.
It is clear.
Yes, miss.
Okay, next we have calculus. Have you ever heard about calculus?
Yes, miss, I've heard about it, but uh,
Okay, calculus is basically a mathematics that is used when we are observing or examining a continuous change, right? Or for example, when we are examining, you can say, how can I explain you that when you are examining some changes, basically calculus is, you can say, a mathematics of differentials, right? You have to differentiate between the two values, that how these two values differentiate through each other. For example, I just show you two yellow colors, right? And I say you, for example, I say that this is a palette. Okay, I say that Huma, is this yellow color is different from this yellow color.
yes, miss, they are different.
Now I say you to calculate the difference between these shades, that how these shades are different, right? Then at this point calculus will help you, right? You
Yes,
will
miss.
make this as a base unit, right? And then you will differentiate this from this base unit, and when you are going to differentiate this from this base unit, you will make an logarithm, and you will make it different, right?
Yes,
So
miss.
basically, calculus is used to, you can say, explain the differentials, right? That how much how this is different from, how A is different from B, how much A is different from B, and how much rate of change is between those two differentials. Okay.
Yes, miss.
I am hopeful that I have made this point clear.
Yes, miss. It's clear.
Okay, so now you will ask that how calculus is used in computer science, right?
Miss.
Okay, so here is the answer, that calculus is used in an array of computer science areas, right? For example, they are including in creating graphs, visual stimulations, problem solving applications, codes in applications, and the static solvers, right? Designing and you can say analyzing of logarithms. So basically, the graphical interface help us to create the calculus, right? Sorry, calculus help us to create the graphical interface that is in the computer. Okay.
Yes, miss.
Any thing that we do with graphics, calculus is the main foundation in that part of you can say graphical information, right? Or presentation, or you can say the graphical program that we are able to you can say make or develop. The calculus help us develop that program. Okay,
Yes, miss.
because calculus is showing us that how much a thing is different from another thing. Okay, now we
Yes, miss.
have discrete math. So in you can say just read out the slide. Teoma, just read this slide, please.
Yes, miss. Yes, miss. I've read it.
Okay, mom. They say that discrete math examine objects that can be represented finitely, right? It includes a variety of topics that can be used to answer various tangible inquiries, right? For example, it involves several concepts including logic, number theory, counting, probability, graph theory, and recurrences, right?
Yes, miss.
For example, I just say you that you have developed a robot, like right, and you have said that I gave some sort of artificial intelligence to it, right? And what happens that I say I just put two vehicles in front of that robot, and I ask that robot to pick the truck. If you have given that robot, you can say, or you have designed some algorithm of that robot on the basis of discrete mathematics, that robot will be able to, you can say, distinguish between truck and you can say normal car, right?
Yes, miss.
Basically, these algorithms are used by, you can say, architects or designers, right? Which used to design the things, or you can say design the buildings, etc. Right? For example, if I say that what is you can say what is when you think about Burj Khalifa, right? What is the thing that you can say come in your mind when you think about Burj Khalifa?
That's the tallest building in the world.
Okay, very good. The tallest building in the world. But what will happen when the tallest building of the world was about to build, right? They were thinking to build a building which will be about 828 meters high, right? So they also have decided that what will be the major part of that building, right? Major part is not the height of that building. The highest you wanted to build a building, the you can say you have to build the foundation of those buildings to more deep to the earth, right? For example, if we
Yes,
are making 800-meter long, you can say building, we have to put at least, for example, 20% of that height in, you can say, the foundation of that building. So, for example, if someone have assigned an architect that please make the tallest building in the world, the architect have to think that what should be the rate of foundation that that building should have. Okay,
yes, miss.
it is easy to build. You can say a building, the tallest building, but you know if you have to make it without any disaster, you have to make its foundation way deeper, right?
Yes, miss.
Understood?
Yes, miss.
Okay, now we have statistics. What you have, do you have any idea about the statistics?
Yes, miss. A 50-50, I can say.
Okay, so just define statistics. Whatever words you have, just define statistics.
So basically, it's graphs and like data and graphs to make it more easier.
Okay, statistics is basically a mathematics in which we, you can say collect, we analyze, or sorry, we collect, we classify, we analyze, and then we represent some data, right? What will we
Yes,
do?
miss.
First of all, we will collect the primary data. We will collect the data, right? For example, I give you that this is a city, For example, I say that go to Jeddah, right? And you have to calculate the population there, right? What will you do? You will first go to the residential areas, right? You will go to residential area. You will give some form to people, and then you collect those form, and by those form you will get that how many people live in this house, how many people live in
Yes,
another house, and then you will got to know that, for example, let me say that there are 5 million people living in Jatta, right? You collected that information,
yes,
right? Now you will classify that information. And how you will classify that on information? You will classify that how many females are there, how many males are there, right? And what are the you can say ratio of youngs, what are the ratio of adults, what are the ratio of old people, right? And then you will classify that how many old people are, how many female are old, how many males are old, right? What you have done, you have
yes,
classified
miss.
that data, right? Now you will interpret that data, or you can say, or represent that data, right? So that the other people who are not able to understand the facts, they will be able to you can say understand the data. What you will do, you will uh, form a graph through that data, right? A pie chart or a graph, right? That will make easier for people to understand that how many people are there, what is the largest population, and you can say what are the stats around their city. Okay.
Yes, miss.
Same these properties are used when you can say when you apply that to computer science, right? So there is a program which names is SPSS. Have you ever heard about SPSS?
No, miss.
Okay. That is basically an statistical software which help you can say the analysts which use the data for you can say for from surveys, or for example that help the students of that help the research students, the students who are doing PhDs and other things, that they help this software help them to you can say classify their surveys or classify the data they have collected through their surveys. Okay.
Yes, miss.
And how that program is developed? That program is developed by you can say the uh, you can say the computer scientists behind that, they develop that you can say program, or they develop that through the statistical algorithms, right? They first add that what will happen if they had a variable, what will happen that if they have the second variable, what will have if they will add a third variable in this program, right? And then they will say that what are the readings of those variables, and after that the when they execute that program, they got the you can say the reliability ratio or in the correlation ratio, and after that they found that what is the relation between their variables. Okay.
Yes, miss.
Okay, so far so good. Have you understood whatever I'm saying, teaching you?
Yes, miss.
Do you have any queries? Please ask for me.
No,
If
miss. It's clear. I understood now.
are you sure?
Yes, miss.
Should I move next?
Yes, miss.
Okay, next we have is okay, statistics was our last mathematics. Okay, so let me revise our lecture a little. In today's lecture, I was going to give you, or you can say, going to explain you that why mathematics is important in computers, right? And then I also have explained to you that how many types of mathematics are used in computer programming. So I have
Yes,
told
miss.
you that what is importance of mathematics in computer program. Basically, we use a basically we should have a thorough, you can say, learning of mathematics while using computer science, or while making, you can say, making programs, developing software. Why? Because we use mathematics to develop you can say algorithms, right? When we develop algorithms,
Yes,
we use mathematics by developing them. Okay. Then these were the some of the, you can say, points that teaches the importance of mathematics. Discrete mathematics is, we have learned that discrete mathematics is used as the foundation of computer science. Then we have learned that mathematics teaches the uses of algorithms. Then we have learned that mathematics provide the analytical skills required in computer science. And then we have
Yes.
learned that mathematical concepts are required in many disciplines of computer science. Right? So if there is any point that you think that is not explained to you well, you can ask me now.
No, it's okay.
Okay, Humam. Next we had that what are the types that are used in computer programming? What are the types of mathematics that are used in computer programming? So the types of you can say mathematics are binary math, college algebra, statistics, calculus, and discrete mathematics. Okay,
Yes, miss.
I have taught you that how binary math is used. Basically, computer understands a
Yes.
binary language, which consists on zeros and ones. So binary maths is, you can say, a foundational math for you can say computer programming. What is college algebra? College algebra gives you you can say insight that how you can develop a program graphically, right? What is that? How statistically we use program? We use that to you can say interpret our data that we have collected, we have classified, and now we have to interpret that data. So we use statistics for that. So now and then we have calculus. Calculus is also used for, you can say, graphical representation of you can say when we use GUI, graphical user interface, we also use calculus, right? So then we have discrete math. Discrete math, for example, if we take an example of probability in discrete math, we see that we use it to you can say develop analytical skills in, you can say, develop analytical skill program in artificial intelligence as well. Okay,
Yes.
so this is your conclusion. What should I conclude? I conclude that yes, mathematics is present in the foundation of computer science, right? And if you want to succeed in any discipline of computer science, it is much better to inculcate a love of mathematics, as that will help you tremendously, right? You should have a thorough understanding of mathematics while you wanted to you can have if you wanted to understand what the math is, what the algebra is, and what the logarithms are, you should have a thorough you can say learning of maths. Okay, so far so
Yes.
good. I so let me tell you that what I am giving you as an homework, right? Okay, what is your assignment? You have to make, you can say you, there is no, you can say hard and fast rule that you have to make this assignment on, you can say Word, or you can say you have to make it on somewhere special. You have to make this assignment anywhere in your, you can say, copy, and you can share that picture of this. What will you do? You will write some of the points which indicates the benefits of mathematics in computing. Okay?
Benefits of mathematics, right?
Right, benefit of mathematics in computing. There should be at least five benefits. Okay?
Oh, okay, okay, miss.